Thank you very much for coming, everyone. My name is Chris Horner. I work on the design systems team at Cash App. And today I want to talk about building kind of like weird and creative UIs with Compose. I'm not talking about, maybe you've seen some of those weird like experimental kind of like visualizers that people post online. I'm still talking about like real user interfaces, but we're going to break out of material and build something kind of different. So the structure of this talk is we're going to look at a UI together and kind of like build it up step by step by step into a finished app. But before I do that, I kind of want to give some context as to why I'm giving this talk in the first place. So here are a bunch of apps, like some screenshots that I took from my phone, and I use all of these all the time. And something that really stuck out to me was just how consistent all of these UIs have become. Like, they're very different apps, well, mostly, but they all kind of function the same way. Like, let's look at these two in particular, Spotify and Pocket Casts. They both play audio. Down to their like now playing bar, it's like the same color between these two very different applications. And honestly, like, my brain kind of loves this, right? Like, when I use an application now, I generally don't think about how I use it. I kind of just like pick it up, and then it's a tool for me to get like something done. It's great. But it also kind of reminds me of something that a designer I work with once said to me when they were talking about their job. And they said, I arrange rectangles. And sometimes if I want to get fancy, I round the corners. Which, you know, I'm not going to name names as to who this was, but let's have a look at these UIs, right? There's an awful lot of rectangles. And in fact, these designers decided to get fancy, and they rounded quite a few of the corners. But as developers and designers, we also know that the rectangles don't stop here. Our whole UI itself is just built out of rectangles. It is rectangles all the way down. And if we think about the frameworks that we work with every day, they're kind of built around rectangles. And this makes sense, right? Like the screen of the actual device we're working with in mobile, it itself starts as a fancy rectangle. And then our job as developers is often to come up with like creative, novel ways to arrange and nest rectangles. That's what we do. And that's honestly kind of productive, right? If we think about what modern design trends are like in mobile at the moment, I feel like flat design, which I'm kind of going to refer to as like an amalgamation of material and what everyone else is kind of like using at the moment for their UIs, there's a lot to like about this flat design approach. So I'm looking at Fitbit here as an example application. It's pretty easy for a designer to whip something like this together. You could think about, if you're familiar at all with Figma, how long it would take you to put this together. It's also pretty simple for a developer to then take those specs from Figma and then build it. There's not a lot of like complicated assets that we need to hand off here. As a user who's using this thing, it's kind of low effort for me to read. There's not a lot of like fancy stuff on the screen I need to parse through. There's just information. It should render fairly quickly. No fancy effects. It's easy to make a design like this responsive. Because we don't have any complicated textures, you could think about how you're going to stretch and scale this thing on different axes. Because it's all flat colors, pretty easy. Dark mode is simple. There's no custom assets for us to export. We should just be able to flip our color palette, and boom, we're supporting an entirely different theme. Great. Except I am going to go throw shade at Fitbit here specifically, because they don't support dark mode. But there is something else about this design that kind of sticks out to me. It's kind of boring, right? And I'm not saying that like all apps need to be the most exciting things. Boring is often really, really good when it comes to getting something done, right? Like if I think about what I use my phone for, like making a phone call, contacting customer support somewhere, maybe I want to navigate, I want to send an email. These aren't exciting, like life-changing kind of events. I just want to use the thing as a tool. I don't want some designer to invent some new pattern. It's fine. But maybe we've gone a little bit too far with all of this consistency, and we've lost some of the magic we used to have. And so tonight I want to go back in time. We're going to go back in time with the magic of Keynote. Is everyone ready? Whoa! It's 2009. How good is that, right? In 2009, iOS looked something like this. We were taking notes on actual notepads. We took news from an actual newsstand. If you wanted to record audio, you spoke into an actual microphone, complete with analog decibel meter. Kind of sick, right? In 2009 as well, HTC, may they rest in peace, came out with the HTC Hero or Magic, I can't remember what this phone was, but it had this Sense UI skin running on top of Android, and there was so much whimsy here. Like, look at when you open the weather widget, and then I know it looks a little bit tacky, but the way the windscreen wiper comes in to get rid of the water droplets, the Web 2.0 glossiness to everything, I absolutely loved this thing. In 2009, we really start to see the decline of one of the all-time greats as well, Winamp. If you are not familiar with Winamp, it was a desktop music player that let you play your local music files, and it looked a little bit like a funky, futuristic cassette player. But one of the reasons why people loved Winamp so much is because you could skin it and make it look like anything you wanted. You could be in charge of how your music player looked, and it was super fun. And people built all kinds of interesting skins. Were all of them good? Absolutely not. They weren't. But I will give these people A+ for creativity, right? At least they could, and they did something fun. And so if you find this as interesting as I do, there is actually a Winamp skin museum you can visit that preserves all of this magic. People are still making skins today because it's fun, so you can go here. But it's not old music players or old versions of Android that I want to talk about tonight. It's actually a different kind of software that I think still has interesting UIs today. And that's video games. They continue to innovate, right? They don't have the same restrictions that we have as app developers because their primary purpose is usually to entertain. Their UIs can kind of serve a theme rather than immediately trying to get something done. And I think some of the UIs here I've chosen are really, really interesting, putting the UI in the game world or really styling it like paper. But it's not these I want to talk about. I want to focus on one video game in particular. This is a video game that has had a lot spoken about its user interface for just how kind of off the wall it is, how creative it is. This game is Persona 5. It was developed I think it was released in 2016, developed by P Studio inside of Atlas. And when I started playing this game and got even just to the main menu, I knew I was in for something special. But let's have a look at how the gameplay takes place. So in a lot of the game, you're in this turn-based kind of structure where you take a turn, the enemies take a turn. The UI is very complicated, but because it's turn-based, you've got time to kind of assess your options and peek through things, right? And you can see there's so much going on. The way the elements explode, the way they kind of launch out of the player character like this, really blurring the line between what is 3D in the game and what is 2D user interface. I just think it's super cool, it's super creative. Why can't we do something like this? There's an obvious influence of manga here. I think we can all see that. Maybe less obvious, though, is the influence of 70s British punk rock magazines, because rebellion is a very big theme of this video game, and so I can't think of kind of a better source material to draw from. But who thinks to look at a 70s punk magazine and think, oh yeah, I can make a UI out of that? Fun, right? Even the main menu, the way the main character holds up his hand to the camera as if to say don't look at me, paparazzi. There's so much style here. But at this point, you might be wondering, This is GDG. We're here to talk about like Android-related stuff. What has this got to do with Android? Well, there is one UI in the game that might be more familiar to us, and that's when the characters are in class, and they want to message each other. And to do that, they pull out their phones. And they use a messaging app. But this is unlike any messaging app I had ever seen before. Even the in-game messaging app here is funky. It's weird. There's so many animations going on. There's a particle system. Is this even possible for like a real app?
Definitely.
That's the question we're going to answer tonight, is can we build this messaging app in Compose UI? But it's breaking a lot of our conventions when you look at this thing, right? Our main screen is not a rectangle. It doesn't fit, even if we like tilt it slightly sideways. All of these portraits up the top, not rectangles. The avatars in our chat log, not rectangles. There's this funky line that goes between each one of our entries. How are we going to render that? And then if we load new messages in, there's so much going on that we're going to have to animate. Let's look at it again slowly, just so we can see what is going on. There's a lot for us to do here. So let's get started. We'll start with something easy, the background. Let's say we get this as a spec from our designer, something a little bit kind of like cleaner, less cluttered. We need to build this. I'll start by declaring whatever the persona red color is, and I'll set that as a background on my box. Great. We do have this splatter effect that kind of appears around the edges. How are we going to display that? Nothing complicated. I'll put an image inside of a box and just set it to fill. Cool. While we're putting things inside of this root container, we'll take care of the IM logo at the top. Nothing interesting here except maybe the offset modifier if you haven't used that before. Great for making these final like tiny tweaks in a layout and you don't want to use padding or have it impact the children of a layout. This isn't terribly interesting. What maybe is the text box. Let's think about the shape of this thing. It's kind of a trapezoid. Really, really odd. And it's going to be difficult for us to draw this kind of generically around each one of our message entries. And you can kind of see the problem I mean when I put in a smaller amount of text. So let's say we want this to wrap around our text. If we just naively stretch and scale it, you can see the left-hand edge here is sort of mushed in a way that doesn't look great. We want it to elegantly scale no matter the length of the text. Something I've used in the past when thinking about like text boxes like this is 9-patches. Very, very old tool in Android. Romain Guy has actually brought it back from the dead, and you can go to this repository here, which has vector 9-patches. If you haven't used them before, they're a way of basically defining parts of an image that you want to stay constant, and other parts that are allowed to scale and stretch. So really good for this scenario of like text boxes. But unfortunately, this isn't going to work for us, and you can maybe see why if I load in another message. And we'll draw a bounding box around each one of our text composables. So think of each one of these as a text composable with a background that we need to render. If I extend the length of that text composable, you can get a sense of what that right-hand edge is doing. It's at a completely different angle depending on the height of the text box. So we can't just stretch the height of the box. It's not going to work for us. What is consistent, however, between these two text boxes is the distance between the text composable itself and then the outside edges. And that's what we can work with. Compose UI actually has this really fun function called generic shape. One of the things I like about generic shape a lot is it gives you this size parameter at the end. And size is fun because you get to say, I don't care how big this thing is going to be at the time I go to write all of this code. I just pass it to me at runtime, and then I'm going to work it out. You can start by calling move to. So you can think of move to as being like you've got your pencil and you're moving it to a particular coordinate above a sheet of paper, but you haven't put it down yet. calling line 2 is like you've put the pencil down on the paper and you're now connecting these 2 points together. You're actually drawing. And you can see here we're actually taking in that size parameter now. We're saying, I don't care what size I happen to be until it comes time to actually render, go all the way to that right-hand edge. Same deal again with the next point. This time we're looking at width and height. Another point. And then finally we call close, that basically says the shape is done, this is what I want to render. Of course, it's not quite this simple, because generic shape, at this point, it's a very drawing focused primitive. It's working in pixels. But generally with designs, we're working in DP. We don't want to care. Thankfully, it's pretty easy for us to say, all right, let's just make this function an extension function on the density type, and then that way we can call 2px on each one of our values. And so now we've got the ability to kind of build up these generic shapes. So you could see how we might do this again for the inner box as well, start to layer up all these different components. This might start to sound kind of tedious to you though, and I totally get it. And if it does, there is a Figma plugin called Shape Composer. And what that does is, if you're familiar with Figma at all, you can define whatever shape you want, and then it will actually output compose code for you. It won't give you the very nice width and height parameters, but it will at least spit out a bunch of code that you can then take and add those if you want. The text itself, I think there's nothing really interesting here except for maybe the custom font. What is interesting is how we're going to render these boxes. And for that, we're going to use the draw behind modifier. One, that makes sense because we want to draw behind the current composable, right? The other thing that's nice about this is draw behind is already itself an extension on top of that density type. So now we can just say, yeah, I want to use my outer box and my inner box. I'm drawing shapes. Great. You might then think, okay, so the API probably has a function like this, draw shape. It does not. It doesn't exist. Instead, what exists is a function called draw outline, but thankfully it's very easy to take a shape and turn it into an outline and then pass it into this API. Lastly, we'll add some padding to kind of match what we're seeing in the game so we get the right bounds. And I'll load up an emulator, push it. Not bad, right? We're looking kind of similar to the video game, except now we're rendering inside of Compose UI, which means we can support things that the original game never did. Let's say we want to actually support accessible font sizes. We can crank it up, and our background will adapt to whatever it happens to be. What about these avatars? So the avatar, it's kind of similar to the text box, right? It's just sort of a bunch of shapes layered one after the other on top of each other. But then we've got this image that we need to render sort of inside the bounds of this, but not quite. Let me reduce the opacity. You can kind of see what I'm talking about here. The bottom and left-hand edges, we're going to need to somehow clip or mask those to the shape of this avatar. How do we do that? Well, if we're thinking about how we render this whole thing, maybe it's a row. We've got our text box. And we'll put the avatar beside the text box in an image. We'll load this up on an emulator just so you can see what I'm talking about. We're going to wrap that avatar image in a box. Same trick as before. We're going to draw a bunch of shapes behind it. But now we need to deal with the mask. And if we think about what that mask looks like, let's draw it for just a second using this lovely magenta color for debug purposes. You can see we're going to want to clip the left and bottom edges, but then we've got as much space as we need to kind of grow up and out of this. What's neat about the Shape API is it's not just for drawing, it's also for clipping. So as long as we pass this in as the last modifier in our chain here, we're going to say clip everything that's inside the box, but all of these modifiers prior to us, we're just going to let it draw. Okay, we've drawn the avatar, and we've drawn part of the box, but part of this whole layout is the message stem that connects the box to the avatar. How do we put this whole layout together? So far what we've got is this, but complexity kind of arises where I want you to pay attention to the stem as this animates in, it stays fairly constant in size, but note how the white line stays vaguely stable, right, as it grows in. It's complicated. You might think, well, it's in between these two items. Could we just put this in between them in a row? Maybe, but we're going to run into some issues. And for part of that, we need to talk about how this text box needs to draw to support this animation. We start with the white part of the text box, like the stem, then the actual full background, then the black part of the stem, and then the final black part of the text box. And this order is actually very important. The reason for that is, and I'll show you, let's look at if we decided to do any other combination of drawing orders, and let's shrink it down a little bit like it does at the start of the animation. We get some pretty nasty artifacts on the left-hand edge here where the stem doesn't line up nicely. It looks a little bit weird. Only the top drawing order there gives us exactly what we want, but that means that the stem and the background box itself have to be kind of like equal children and in charge of their own drawing order together to put the whole puzzle together. So we can't put the stem as a separate child in a row. So we have to have this. We don't have a choice. Fine. Could we maybe just look at the text box? If we're going to draw that stem, could we add an offset like before? Just shift it a little bit to the left and it goes over the top. Kind of annoying. We're left with a little gap on the right-hand side. And the reason why that's annoying is let's load in another message that's maybe a little bit longer. We want to make sure we're taking up the whole width available to us. Kind of looks a bit gross to have that gap on the right-hand side. There's also some complicated rules here. If the message is short, it anchors to the bottom of the avatar. If it's long, it anchors to the top of the avatar. And this is really where I started to think that all of these custom rules around how this thing lays out really lend themselves to a custom layout in Compose. And they're nowhere near as scary as they were in Views, thankfully. A quick refresher on how these things work in Compose. You have a content block where you throw all of your composables that you want to position somewhere on the screen. And then you get another block with measurables and constraints. Typically, the way this works is you iterate over each one of your measurables, you call measure, and it gives you a placeable. Then for a given width and height, you place each one of your placeables somewhere on the screen. This is a very generic kind of layout if you were building something that would solve all kinds of problems. We're not doing that though. We're laying out this, exactly. And this means that we can cheat and make it specific and readable. First thing I'm going to do is say our content is only ever going to be avatar and text box. We never need to care about anything else. What that also means is we can use Kotlin's destructured declarations on our measurables. I always forget that I can do this with lists. I do it with data classes all the time, but I forget that it's an option that I can just say, yeah, I know the sizes too, let's just pull them out and name them. Pretty cool. Let's get our placeables. I'm going to call measure on the avatar. It doesn't need anything custom done for it. It's just going to be as big as it's going to be. The text box, however, we need to do some measuring. We actually need to take into account what is the whole width we have available to us, but then minus whatever the avatar decided its width was, but then add back in a certain amount of overlap to get the perfect kind of size. Once we've got that size, then it's easy for us to update some constraints, measure the measurable, get the placeable. We need to work out what our width and height are going to be. Not too hard, don't need to pay too much attention. Let's lay these things out, given that width and height. The avatar is always going to be in the top left, 0, 0. The text itself is slightly more complicated because it depends if it is taller or the avatar is taller, but you actually then just get to place it however you want. Slightly complicated, but what you have is like 16-ish lines of code that do this exact one complicated layout rule for you now, contained inside of one spot, which we could never really do before with views, and I think is kind of cool. If we do this a bunch of times inside of a list, we start to get closer to what the video game is showing us. Worth noting here, I'm going to display all of these inside of a lazy column. The reason I'm doing that is I don't know how many messages we're going to have, we need to scroll, we've got to recycle, probably a good idea. But if we're using lazy column and it's recycling, then how are we going to draw the line between each one of these entries? This was by far the hardest part of building this thing. Let's break down how this thing works. Let's inspect its behavior. It starts by anchoring itself to the very first item in the list. It then zigzags left and right. And note that it kind of does this by a certain random offset as well. It's never quite the same each time. And then it finally anchors itself to the very last item again. Also, if we animate in the next item, you can kind of see that it goes from that anchored position to a final, what I'm going to call a final position on the left-hand side or the right-hand side. Looks a little bit weird in slow motion, right? But when you're playing the game, it kind of feels natural. So we need to do this jump right at the end. And before I go on, we kind of need to do a little bit of boring groundwork. I am so sorry, but we need to talk about modeling data, everyone's favorite topic. If we think about what the shape of this thing is, for each one of our messages, there's a sender. We'll say it has an image and a color. We can use an enum because it's a video game. We know how many characters there are. Then there's the message itself. That's kind of the composite of whoever the sender was and the text of the message they sent. But then we need to wrap that one level further, and we need to care about the line coordinates of each one of our entries. What do I mean by line coordinates? I'm talking about 2 points here beside each one of our message entries that represent where we're going to draw parts of this line. We could represent this with maybe one value and a width, because the width does actually vary as it goes throughout the UI. But I think for drawing purposes, it's actually easier for us to keep track of them as 2 different points. And we're going to use Compose UI's offset type. And that's important, and we'll get back to why in a bit. We'll wrap all of this in an entry. So you can think of an entry as being the final kind of like box that has everything we need to render one of these things on a screen. Where do we store all of this data? I see a lot of people taking photos. All of these slides are online. You can look at them. There's a speaker deck. You don't need to worry about taking photos. Where do we store all of this stuff? View model is one option. I mean, that's usually where Android developers think about storing all of their stuff that goes on a screen. But I would actually argue that a UI state object is a better fit here. By UI state, I'm talking about things like, maybe you've called remember scroll state, remember pager state, all of these things that are in the Compose UI framework that are building UI state classes. We're going to build one too. The reason for this is your view model is really good at just like the actual kind of like data stuff. But we're talking about storing pixel information. That's something the view model has absolutely no business knowing about. They're 2 very different layers. And so if you want to think about how we put this stuff together, the view model feeds data into your UI state, which then finally feeds into your lazy column to render all of your stuff. To make one of these, it's not terribly complicated. We have our own remember transcript state. So we're going to have a transcript that holds all of these entries. Worth noting, I'm keying this off of the density in this remember call because I'm doing a bunch of pixel calculations. If the density ever happens to change, maybe we're on a foldable, I don't know. You go to a different screen, your density is going to change. You want to throw all of this information out the window and start again. Transcript state itself can also be pretty simple. We keep track of all of our entries using a compose state type and then expose it through this by entries. We're using stable here to just pinky swear to the compose compiler to say like, yes, if any one of our public properties change, we're going to notify you and recompose. So this entries, if you think about what it does over time, it might have 1, and then 2, and then 3, and every time it changes, it's going to cause another recomposition. But how do we calculate the line coordinates for each one of these entries? Some boring maths. The left-hand side is like half the width of the avatar at minus half the width of the line width, and we get a point. And then the right-hand side can just be the left plus whatever the width is. And the y coordinate is always half the height of the avatar, whatever, boring. What's interesting is then how we store all of these with these two offset types in line coordinates. If we were to draw this from the previous entry to this one, we've got all of these different coordinates now, it would look like this. But what if we wanted to go like left or right? How would we calculate those coordinates? Well, we know that we alternate left and right every time, so we can look at our index and see, is this thing divisible by 2 or not? If it is, we'll go one way. If not, we'll go the other way by some random offset. We'll calculate that shift and then just multiply it by that direction. It means we're guaranteed to go left and right. If we start drawing these now, it would look like this, and then another one, and then another one. And if we color it black and give it a drop shadow, it's starting to look like the video game. But we said all of this is inside of a lazy column, right? Lazy column is doing a lot of bookkeeping here. It itself has its own UI state that it wants you to remember. We're going to have that alongside our state and all of our entries that are driving this list. And we're pumping them into this lazy column. This made me think like, okay, an approach here we can adopt is to have some sort of background line composable. It's going to sit behind our lazy column, and we should have all of the data we need with the list state and all of our entries to render the line. What would that look like? Well, lazy list state has this very fun type on it called layout info. Layout info specifically has this property that we care about. The main axis offset of the item in pixels, it is relative to the start of the lazy list container, which is perfect, right? Like that's this point of this yellow message, right, where it is relative to the start of the top. And then as we scroll, we should get notified of new positions here. And so we should know where the line is going to be for each one of our entries. The basic approach I thought of using here was to grab a canvas. I've got all of these points. I was going to draw stuff. Don't pay too much attention to this because when I actually push this to a device, looking at it stationary, it's not too bad. But as you start to scroll, it looks kind of weird. It's not actually updating every single frame. It's kind of janky. And then maybe even more annoying is it's not in sync with the Android overscroll effect either. We're moving on top of it, which sucks. Back to the drawing board. The problem we have with this UI is each one of our messages is a different height. We can't guarantee what the height of each one of these things is going to be. And so it's tricky for us to say, like, well, draw a line from one to the other. I don't know how far that's going to be. So you can think of this as kind of like the total height of each one of our messages is variable. What's constant, however, is the amount of height into the next message. I'm going to call this the overlap height. So how far from our bottom into the next message do we need to go to complete a line? And we know that that avatar is always going to be sitting at 0, 0. That means if we know how big one message is, that like one message is drawing, it can say, well, if I just rendered a little bit extra, I could connect to the next message. So say we set this as like the background of a row. One nice thing we can abuse in Compose UI compared to views is that now our children and ourselves, we aren't clipped to our bounds by default anymore. We render outside of our bounds. Kind of great. It means we're going to connect down to the next item. If we do this for each one of our entries, it means that we can start to build up that line shape. How do we do that? We'll make a draw connecting line modifier. It's going to take in 2 entries. One we know is not null, that's us. The next one is nullable because maybe we're the last entry in the list, but we probably have a next one. And here we're going to use draw with cache. Draw with cache I really like for a couple of reasons. One of them is that it lets you do a bunch of calculations and then you hold onto them in memory so long as the size of whatever you're drawing into doesn't change. And that's great because we're going to allocate a path object and then do a bunch of maths, and then I'm like, cool, I don't want to do this ever again. I've got the points I need to draw. The actual drawing code happens in onDrawBehind. This is very similar to the shape building code that we had before. But this time we're saying, hey, with our line path, we're going to move and move and move and draw lines, and it's great. The only thing that's maybe worth paying attention to here is the fact that we're calling rewind at the very start. And that's saying we want to use the same path object. We don't want to allocate a new path every single frame. So we'll call rewind and we'll reuse the same path object. The background was actually, the drop shadow was kind of more annoying. Here I couldn't do it quite with just pure compose code. I had to dip back into some older Android drawing APIs, but this does let you get at the blur mask filter to make like nice looking shadows. And you've got this draw into canvas call. So you can say, this is where I want to like, yeah, I can't now make this a Kotlin multi-platform application, but now I'm drawing some cool Android code, so it's fine. That gets you across the line. If we push this to an emulator now, look at that. We're like way, way closer to the actual video game. It scrolls very smoothly. I'm very happy with it. But we haven't animated anything yet. We've got to make this thing move. How do we do that? Well, we've got this entry type already that's storing the message and all of the line coordinates. Animation state really kind of belongs to each one of these entries as well. We want to keep track of the line progress. So you can think of this as where are we as we're drawing this line from one message to another in terms of a percentage going from 0 to 1. So if we're 0.5, the line would be like halfway down. We need to keep track of the avatar background and foreground, the background being the yellow shape, the foreground being the head. Each one of these need to animate in with its scale, but they operate at different times, so we have to keep track of two different states. The text box, even more complicated again, because the different axes of the text box animate at different rates, but that's fine, we'll keep track of that too, along with the alpha. We've got all of these things, how do we put them together? How do we like actually build these state objects for each one of these? Compose UI's animatable type. I really like this type for two reasons. The first one being you get to pass in an initial value. So what's fun about these animations is a lot of them start kind of like mostly finished. So the background scale here, it starts at 60%. Looks a bit weird, but in motion, when you're actually playing the game, it's what makes it feel snappy and responsive. You're like almost done, you see that final part of motion. The other reason I like it is because it's got this nice coroutine based API. So here we get to say like, yes, you started at 0.6%, and then animate to is a suspend function, and we say, over 300 milliseconds, get to your final value. Of course, this isn't actually the type we want to give to our UI. This isn't animatable. I don't want our UI to know how the state sausage was made. I just want to give it a value. Thankfully, there is a nice asState function that we can call, and that lets us kind of wrap it all together, and the UI doesn't need to care. So here's why I really like this coroutine-based API of animatable, is it lets us be quite expressive for things that need to occur over time with different steps. So for the foreground, the head here, for example, we want to say, start at 0, I don't want to render you, but then after 160 milliseconds, snap yourself to immediately being like 80% scaled, and then finally, over 150 milliseconds, get to the last 100%. When we actually consume this code, it's nice and simple. The scale can just be like, yeah, whatever the avatar background scale is, set that to the scale. The avatar foreground is slightly more complicated, and that's because we don't scale from the center. We're kind of changing that default behavior. And if we want to adjust that, then we have to use this graphics layer modifier. And we say, yep, the transform origin of this operation we're about to do, it exists here, kind of below where the avatar image is. We want to say go halfway across and then to 115% kind of below the avatar's total coordinates. And so we can get that nice scale up effect from this point. Lastly, the line. So we said our drawing code looks something like this, right? Where we had a bottom left, bottom right of one entry, and then we draw the line from top left, top right to bottom left, bottom right. The difference here really is we kind of want to calculate a point in between the start and the end. There is a way we can do that. Compose UI exposes this really fun but weird looking function called lerp, and that means linearly interpolate. There's actually a bunch of lerp functions that you can use. There's ones for float, for integer, for long, for all of these like kind of normal primitives, but then they've also written some for some of the more like graphics-oriented types, like offset, for example, things that represent a point in two-dimensional space. You can also linearly interpolate between them. Very, very handy. So if we say had a point, like our fraction was 0.5, it would give you the exact point in 2D space on a line in between two coordinates. Very handy. You might be thinking, well, Chris, this thing is returning an offset type, and we're doing that inside of onDrawBehind, and this is running every single frame while we're animating. Doesn't it kind of suck that we're creating a new offset object every time? To which I say, that would suck, but the fun part about offset is that it is a Kotlin value class. What's neat about that is when you're writing your code, you get to interact with this thing as if it were a class, as if it had methods and types. But then actually when this is compiled, the x and y coordinates, the two 32-bit floats, get packed into a single 64-bit long for you. And so you don't pay the penalty of actually allocating an object. The Kotlin compiler takes care of like masking all of that, and really at runtime, your cost is primitives plus some bitwise operations. So if we put all of that together, what does it look like? It's kind of hard to tell when it's running at full speed, actually, on a tiny like projectile like this. Let's like look at it in slow motion again to see how we did. Kind of all right with the way things scale up, move in, the delay of the avatar, the line does the jump exactly the same way we did before. We pieced everything together. There is a little bit here we've missed, and I'll get back to that in a second. But I first want to touch on like what are the takeaways of this talk? Why am I doing this? And one of the things I really like about Compose UI is it's a very fun UI framework to play in. You don't necessarily need to immediately run to something like Figma to sketch out an idea. You can bang out Compose code pretty quickly and do some really funky stuff with it. So have a play. Some UIs should definitely be boring, but I'm very, very sad that now all of them are boring, and I miss when apps did weird stuff. And we've lost some of the magic with all of this consistency that we've gained. So not everywhere, but sometimes, somewhere, put a little bit of whimsy in the UI. If you don't know where to draw that inspiration from, video games have left us in the dust in terms of how they innovate with their UIs. And if you also are kind of interested in what people have been doing in this space, there's actually a site called Game UI Database, and the folks who maintain this have done an excellent job of maintaining like kind of a very searchable database. There are videos, you can look for terms, there's all kinds of things to draw from here. What was interesting when I was putting this presentation together was that the developers actually released a follow-up game to Persona 5, one called Metaphor Refantatio, which has its own kind of like very funky and unique style. But what I loved about this when it came out was something the director said after it released. And he was just like, hey, making all of these really beautiful menus is actually really annoying. Which it is, right? You saw all of the like painful stuff we had to do to make this, to get this level of creativity. But I think it's worth it, and it makes this thing that people are still talking about today after this game came out in 2016. It's still lauded for having one of the most creative UIs. The other thing I want to touch on while I'm here is actually the original conference I gave this talk at was Droid Kaigi. That was in Tokyo in September last year, and it was amazing. And I encourage all of you to, as we're talking about applying to speak at things, this is one conference I would really like highly recommend in terms of like one of the biggest in APAC. They do a lot to make people who don't speak Japanese feel very welcome there. When you give your talk, you get to do it in English, and you are live translated into Japanese while you're there, like a little bit like the UN. Everyone has little like microphones attached, which is super fun. The conference itself is massive, thousands of people. There was JetBrains there giving a talk on some Kotlin multi-platform stuff. What I actually found maybe more interesting about all of this was the different types of booths that the Japanese companies set up while they're there. They've got interactive games that you can play. By far, one of the most interesting ones was this one here, where this company had a laptop set up where you could write compose code, and then that was connected to a real printer that would then print out your compose UI designs like on these receipts. It was super fun. There's also lots of other side activities, like there's nail painting. You want to go get a little android, like paint it on your nails, you can do it. It's awesome. The line was massive. I missed out. I was very sad. The catering is next level. You get to have sashimi. The organizers brew their own beer as well for the event. So I don't know what more I could do to convince you to come check this conference out. It's super fun. They also have a budget for flying people there and speaking. Even more fun, if you do speak there, they will do your hair and makeup as well, which was a very new experience for me, but one that I really enjoyed, highly recommend. But lastly, with this whole thing that I've just built here, if it is interesting to you, there's so much that we didn't get to. How do we draw these kind of funky portraits up the top? How do we draw the now typing indicator down the bottom? There's a whole particle system in the background that we didn't get to today. And I don't want this talk to be a draw a rest of the owl kind of thing. So all of this code is open source. The complete app is there at this GitHub URL. If you want slides, they're all here at this QR code, so you don't need to worry about taking photos. It's all there. If you want a gas bag about this stuff, I am on the GDG Slack, but you can also find me on Blue Sky here. But with that, thank you very much for coming tonight. Appreciate it.
Any questions for Chris?
Yes.
Awesome talk, Chris. I was just wondering, in terms of getting some of those imaginative UIs, there seems to be sort of a niche movement of taking inspiration from also sci-fi as well as games and trying to implement elements of that. I wonder, have you looked into any of those?
Absolutely.
That part as well?
Yes, I had way more slides dedicated to, there are groups that, their job is also to build UIs for sci-fi, films and things. People, movie companies go to them to say, build us a weird UI, and they get to do that. Cool. Yeah, I didn't have time to touch on it, but yes.
Thank you so much. So I was actually I'm new to Compose and trying to build game. And as you said, it has unconventional rectangle shape. So the first I discovered is canvas, and I wonder if generic shape in canvas is different, or it's pretty much the same on top of each other, or?
A little bit. So the generic shape gives you that shape type that you can then turn into an outline. That's often really good when you want to interface with all of the other compose types. So when you draw to a canvas, you're free to do whatever you want, but you're no longer participating in the UI system really at large. You're not contributing to say I want the text to have this or mask something in this way. You can build your whole app inside a canvas if you want. But part of this, why I brought up the accessible text scaling thing was to say look, we're still participating in Android's normal rules of a UI. We're building a usable user interface.
Okay.
And so that's when you need to use something like shape rather than just doing canvas for everything. Yeah.
Okay, thank you. Can I ask the second question? Sorry. It's just when I try to use canvas, the finding coordinates are hard. How did you find yours? And I don't know. I tried to trace it manually by having a grid on Figma and then just copy over the values of the points, and that's how I did it. And so I wonder if there is an easier way for it. Yeah.
The Shape Composer plugin will do a lot of your heavy lifting there, where it actually will just output the compose code for you.
What was it again?
Shape Composer.
Shape Composer. Okay.
Yeah.
Thank you so much. Okay. Thank you so much for that.
Totally fine. I also found out about that after I did everything, though, which is kind of annoying. So I had a bunch of slides before, actually, about here's how you would use any kind of vector editing program to find, say the designer gave you this weird thing, and you're I know that I'm going to have to work out how to draw this thing with code. How do I work out what these coordinates are? And I had a whole bunch of slides of step-by-step, here's how you look at the coordinates inside of the bounds during using Affinity Designer or whatever. And then I found that Figma plugin. Yeah.
I'd say also try and avoid doing everything in Canvas if you can, because you lose a lot of accessibility.
Yep.
So like you can't take text out and images out from the OS anymore. It's a big problem in Chrome, like maps, trying to download a picture, it sucks.
At the front here.
You know, I kind of realized a funny coincidence. I mean, I know you're talking about Compose AI. Within the Unity tool, funnily enough, lerp, there's something called a lerp curve, which actually is used for navigation and for creating basic like enemies. It just got me thinking. I'm like, you could technically use Unity. I mean, since you're literally taking inspiration from a game to make a UI, you could actually try making this kind of UI in a game engine.
You could, but as Andreas just said, you kind of lose a lot of the things that Android gives you out of the box with accessibility. Because ultimately, like when you're operating inside of Unity, like I know that it does have tools to kind of like add that stuff, but it's not the same kind of like first-class citizen to a screen reader the same way that a regular like kind of semantic tree will be in Compose, and you're going to lose a lot there. So that, and by its nature as well, running inside of a game engine, you're bringing a whole other like world to the table. This is just the overhead of like bundling Compose in your app and then running with it.
Just on that though, one thing that always worries me about the Google code is it's almost never backward compatible. So I spend most of my time trying to build stuff that's already bad in Unity. Firebase gives me a headache every time. I just worry that Compose, like in the future, are Google going to make my code backward compatible, or is it just going to say we're replacing this class and you need to rewrite your code like they usually do? Because it's a lot of effort when, you know, you waste a lot of time trying to then work out how to do it the new way. So if are they the Firebase developers? Because I want to strangle some of them.
Different team. And in terms of backwards compatibility, that's one of the real advantages of Compose, is that it's unbundled from the system. That's one of the problems we ran into all the time with the Vue framework, is you had to juggle so many app compat libs.
Yeah.
Now we're just shipping the whole UI framework with our apps. Yeah, it sucks, it's big, but it's totally worth it because now we don't have those headaches that Swift UI developers are discovering and are having so much fun with.
Does it play well with other libraries?
Compose.
Yeah.
Yeah, it's kind of up to you. Yeah. Suru.
Speaking of bundled from the system, do you miss any Vue APIs on Compose? And
Yes.
if so, what would that be?
The thing that's actually really bothering me at the moment is the Spring Animation API is nowhere near as robust in Compose as it was in base Android. You cannot specify an initial velocity on a spring in Compose. If you're using an animatable, you can do a whole like animate decay thing and get there if you want to like have a spring be based off of gesture animations, but it's annoying, and you can't do it if you just have a spring spec, if you need to provide an animation spec somewhere. That sucks.
Recyclables had this decorator API.
Yeah,
That's kind of
yeah,
missing.
that was a good one.
Yeah.
I also wish Lazy Column was as efficient as RecycleView. Sorry, yeah, RecycleView is just way faster still.
I just wanted to ask, what game are you building next?
Oh man, I did play through some of Metaphor. I don't know, we'll see.